Hi everyone, we have got a question on phytomining and copper mining in general. It's from Chemistry Paper 2, this is from Combined Science. It's in the using resources topic. So, high-grade copper resources are now difficult to find. Phytomining is used to extract copper from low-grade ores. So an ore is a rock that contains minerals that have the metal in that you're looking for in enough quantities to make it worthwhile extracting it from. And phytomining is a method used to get metals such as copper without having to mine it out of the ground. So it's kind of like an alternative method of mining that uses living organisms rather than mining, because mining can be quite bad for the environment. So there are 5 stages to phytomining. These are the stages, but they're not in the correct order. We have to put them in the correct order. So first of all, the plants that are growing in areas where these minerals are in the ground, they absorb those metal compounds. So in this case, copper. So a plant will actually absorb a copper compound from the soil. Next up, those plants get harvested, so removed from the ground. They will then get burnt, and in the ashes from the plants, those copper compounds will be found. And then they get dissolved in acid, and then that acidic solution will be electrolyzed, the copper extracted that way. So it's quite a slow process, but it does reduce that need to mine directly out of the ground. So we've got then it's BDC, was it BDCA? Okay. So give 2 disadvantages of phytomining compared with traditional mining methods, but we're not allowed to refer to the cost. The main disadvantage is just how slow it is, because obviously you have to wait for those plants to grow. So much slower than regular mining. It also requires a lot of land to grow the plants, or to find plants that are growing in a high enough quantity. And also they don't produce as much of a yield that you would need to meet the demand. So let's go with the large area of land required. This next question is very involved, so make sure you're really focused on this one. It's to do with the energy needed to obtain copper by either recycling it or extracting the ore. So in 1 year, 8.89 times 10 to the power of 9 kilograms of copper was produced. So that is our total amount of copper produced. Now 41% of that copper came from recycled copper. And then it tells us the energy needed to produce 1 kilogram of copper from the ore, so that is the extraction method, is 70.4 megajoules. And the energy needed to produce 1 kilogram of recycled copper is only 27.2 megajoules. So you see it takes a lot less energy to recycle it than it does to mine it and extract it in the first place. We have to calculate the difference in energy used if all of the copper was produced from recycling. It's a 5-mark question. There's quite a few steps, and the first step here is we need to work out the energy used by recycling over a year. So we're told the energy to produce 1 kilogram, we're told how much copper is produced, 41% of that is from recycled, so we need to factor those 3 in to work out the total energy used by recycling. So to do that, we need the energy for 1 kilogram, which is 27.2 megajoules. We're going to times that by how much copper is produced, put that in brackets. Because only 41% of it is actually produced this way with this energy, we're going to times it by 41%, which is 0.41. And that equals 9.914 times 10 to the 10. So this is the energy that's used by recycling over 1 year. And we're going to do the same thing for the energy used over 1 year if it's just extracted, which makes up 59%. So same as before, we're going to take the energy needed for 1 kilogram of copper to be extracted, which is 70.4 megajoules, times it by how much copper is produced, 8.89 times 10 to the 9. But because only 59% of it's produced this way, we're going to times it by 59%, which is 0.59. And that gives us 3.693 times 10 to the power of 11. So this is more energy because it's increased by a factor of 10. So this is the energy used by extracting copper. So this takes up more energy. So we'll just do a little arrow there to show it takes up more energy this way to extract it. So the next step is to work out the total consumption over a year by adding these two values together to get 100%. So that was 3.693 times 10 to the power of 11 plus 9.914 times 10 to the power of 10, which is 4.6844 times 10 to the power of 11. This is our total energy total energy used to obtain copper by both methods. Now we need to work out how much energy it would use if we only recycled existing copper. So to work out how much energy would be used by just recycling copper, we're going to basically do this equation here, but instead of timesing it by 0.41, we're just going to leave it because we're effectively timesing it by 100%, which is just timesing it by 1. So it's going to be 27.2 times 8.89 times 10 to the power of 9, which equals 2.418 times 10 to the power of 11. So this is the energy required if it was just recycled. Energy use for 100% recycling. So this is also an important value. So this is the energy required if we just extract it, because we've added those two values up. This is the energy required if we just recycle. And then we need to work out the difference. So the saving is going to be that value minus this value. So that's our final step. 4.684 times 10 to the power of 11 minus 2.418 times 10 to the power of 11. That equals 2.27 times 10 to the power of 11. So our answer is 2.27 times 10 to the power of 11 megajoules saved if we just recycle copper. If you're still with me, well done, and thanks for listening. I hope that helps.